Problem 16. In a table tennis tournament, every participant played each other participant exactly once. Although there are twice as many right-handed players as left-handed players, the number of games won by left-handed players was 40% more than the number of games won by right-handed players. There are no ties and no ambidextrous players. What is the total number of games played? So we know the number of games played by left-handed players plus the number of games played by right-handed players is equal to the total amount of games. And we're also told that the number of games won by left-handed players was 40% more than the number of games won by right-handed players. So the number of games won by left-handed players is equals to 1.4 R. So we can substitute this equation into here, and we get 1.4 R plus R equals G. So we get 2.4 R equals G. So we know our answer must be a number that's divisible by 2.4, right? So we can test out all the answers, and we know 15 isn't divisible, 45 isn't, and 66 isn't. 36 and 48 are. So that leaves us with two more answer choices. Okay, now let's look at, for example, now let's look at this. If we have two players, player A, player B, how many times did they play each other? They play each other once. If we have three players, A, B, C, A plays B once, A plays C once, so that's 2, plus B plays C once, 2 plus 1. If we have four players, A plays B once, C once, and D once, so that's 3, plus B and C once, B and D once, plus 2, and C and D once, so plus 1. And we can see every time, for example, if there's two players, there's only going to be the biggest number that we add on is going to be 1. If we have 3 players, the biggest number we add on is going to be 2. So the biggest number we add on is always going to be 1 less than the total amount of players we have. Okay, so if we have n players, we're going to have 1 plus 2 plus 3 plus all the way to n minus 1, right? So the formula for this is going to be, the formula for the n players is going to be n minus 1 times n minus 1 plus 1 over 2, which is equals to n minus 1 times n over 2 equals to n squared minus n over 2, okay? That means one of these two answers, 36 or 48, they should fit into this equation. Let's test 48 first. Okay, no, let's test 36 first. N squared minus n over 2 equals to 36. So n squared minus n equals to 72. 72. So n squared minus n minus 72 equals to 0. Okay, so then we know, so that when we factorize that, we get n plus 8 times n minus 9 equals to 0. Okay, so that works, right? Well, we know, so then we know 36 is going to be the answer, so it's choice B. And let's just try, let's try D just in case. Okay, so n squared minus n over 2 equals to 48. So n squared minus n equals to 96. N squared minus n minus 96 equals 0. Is there any way we can factorize this? With, I mean, okay, yeah, there doesn't look like a way we can factorize this to yield a integer answer, which means our answer is just going to be choice B, 36.